Hey guys, Mr. Krenz here. In this video, I'm going to go through a second example, a little more complicated example of applying the chain rule to find the derivative of a more complicated function. So I have g of t is equal to the tangent of 5 minus the sine of 2t, and I want to find the derivative. So g prime of t. And to do this, I'm going to use the kind of the outside-inside approach to find the derivative here. So if tangent of something says, okay, take the derivative of tangent, which is secant squared. So I take the derivative of that, and I don't change the inside of it. But now I have to multiply it by the derivative of the middle. And instead of doing that right away, I'm just going to write 5 minus sine 2t, and I'll put a prime there. Say, okay, the derivative of the outside, leave the inside the same, and then multiply it by the derivative of the inside. So this would be the first application of the chain rule. But to actually find out what this is now, I have to take the derivative of this part. So secant squared 5 minus sine 2t times, alright, let's see, the derivative of 5 would be 0 because it's a constant. And now with negative sine 2t, I'm going to have to apply the chain rule to this part. So see, the derivative of negative sine is going to be the negative cosine. So leave that part the same, then multiply it by the derivative of the inside of the sine function, which is just 2. Okay. So now I have a big, ugly expression, secant squared of 5 minus sine 2t times negative cosine of 2t times 2. I'm just going to kind of clean this up, pull the constants out in front. So I have a negative and a 2, so negative 2. And then I'll say secant squared 5 minus sine of 2t, cosine of 2t. Right. So it's a big expression, but that's fairly simplified here, and it wasn't too difficult to find. Just took two applications of the chain rule. And derivative of the outside, leave the inside the same, then multiply by the derivative of the inside, and keep doing that until you don't have to apply the chain rule.